Good morning, friends. Today we are going to learn about Booth's algorithm. This algorithm is used for multiplying binary numbers. This binary number can be a signed binary number or a unsigned binary number. With the help of this algorithm, you are able to reduce the number of partial products generated during traditional multiplication algorithm. Let us look into the key concepts. So what are signed numbers? Signed binary numbers are the numbers which have the most significant bit is 1. Booth multiplier algorithm reduces the number of partial products. It uses radix to Booth encoding style. So here we have to learn about the key concepts or key terminologies through which we are able to understand our multiplication algorithm. So whenever we going to multiply any two numbers, we have two operands. One is called as multiplicand and the other one is called as multiplier. So multiplicand is in this algorithm is been used as M and multiplier has been represented as Q. So let us dive into the algorithm. First of all, we have to initialize two variables. One of the variable is A. A is been initialized as 0. Here one additional bit is being considered, that is having index Q minus 1. So whenever we talk about Q, so let us assume that Q is having a 4-bit number. So it will be Q3, Q2, Q1 and Q0. So we are going to consider additional bit Q minus 1 which has been used for both algorithm. So we are going to initialize variables A, Q minus 1, M with the value which has been created by user, that is multiplicand, and multiplier value to the Q. The number of bits N is been represented as number of bits which can be calculated from the number of bits of multiplier. As we proceed further, we are going to check the value of Q0 and Q minus 1. So if the value is 0, 1, if the value is 0, 1, we are going to perform A is equals to A plus M operation. If the value is 1, 0, we are going to perform A is equals to A minus M operation. Or if the value is 0, 0 or 1, 1, we perform operation is operation arithmetic shift right. Okay, and we are going to decrement the value of n which represent the number of iterations till performed. In the next step, we are going to check whether the n is 0. If the value of n is 0, we come down to result. If it is no, then we are going to iterate it again. So the steps which have been involved in Booth's algorithm is the first phase is initialization phase. We are going to have two operands, that is M and Q, one extra bit Q minus 1 which is needed to be initialized by 0, and this bit is being used during bit inspection. So next step will be bit pair inspection. Booth's algorithm inspects the current least significant bits of multiplier Q0 and the extra bit Q minus 1. Based on the pair of bits, if the value is 1, 0, we are going to perform A minus M. If the value is 0, 1, we are going to perform A plus M. If the value is 0, 0 or 1, 1, we are going to perform no operation. And finally, we are going to perform arithmetic shift operation after that. After each bit is processed, each bit pair is processed, we are going to perform arithmetic shift right of the combined result A and Q minus 1. We are going to perform this process until the value of n becomes 0. So let us consider an example for Booth's algorithm. Assuming multiplier value for multiplication value to be 0011, in decimal it is equivalent to 3. Since MSB is 0, it means that it is a positive number, and assuming Q to be 1011, since MSB is a 1, it means that it represents a negative number. So first of all, we just need to calculate the decimal equivalent of 1011. So 1011 can be represented in decimal as taking 2's complement. So this will be 0100 plus 1. This will be 0101, which is equivalent to 5. So this means that the number 1011 represents minus 5 in decimal. So this means that we are going to multiply 3 with minus 5, which results in equivalent decimal value to be 15, minus 15. Now this minus 15 can be represented in binary as taking 15 into the consideration. So it is 1111 and appending 0000 for getting the 8-bit value. Taking the 2's complement of it, 110 111 10000 and adding 1 to it. So this will result in 11110001. So this is the equivalent value that we are expecting from the multiplication of 3 into minus 5. So let me just erase all those things and focusing upon the Booth multiplier algorithm. So this is the final answer which we are expecting from the multiplication. Okay. So to start with algorithm, we initialize few variable as per the algorithmic approach, and that is going to the number of bits. So here number of bits of q is 4. It means that n will be initialized with value 4. Then accumulator, that is a, initialized with value 0. Q multiplier value, where q is 1011, and one more bit q minus 1, that is being initialized with 0. Here we are going to list out the operation. So this operation is basically initialize operation. Okay. Now next, we are going to inspect the bit pair. So bit pair is 10. This represents a minus m. So the operation which we are going to perform is a minus m. So a is 0000 currently, and m is 10011. So first of all, we can represent minus m, or you can say that a, we can perform addition of 2's complement of m. So let us calculate first 2's complement of m. So m is 0011. First we need to take 1's complement, so 1100, adding 1 to it to get the 2's complement equivalent. So this is 1101, that is 2's complement of m. 1101 and adding it 1101, we are getting as the final result. So we are going to write this value 1101 under the A column. The value of q is 1011 as we have not performed any operation onto it, then the value of q minus 1 is still 0. In the first iteration, the next operation is performing arithmetic shift right. So we are going to perform ASR onto this. Now, in order to calculate ASR, we are going to perform arithmetic shift right. That is, this one is been shifted over here, and we are going to shift the value of 1 to it, and the value of 1 is been shifted to q minus 1 part. So the resultant value is 1110. This one is shifted over here. It means that this becomes 1101, and this one is shifted over here. This results in 1. And we are going to perform n is equals to n minus 1. It means that n becomes 3. Now the next thing is to check bit pair. So here bit pair says that it is 1 1. So it means that there will be only arithmetic shift right operation, and n is equals to n minus 1. So we are going to perform arithmetic shift right, and n is equals to n minus 1. This will result in this n becomes 2. Again we are going to shift, so it means that this operation is needed to be performed. So it will result in 1 1 1 1, and this 0 is been shifted. So it means that 0 1 1 0, and this one is shifted over here. So it results in 0 1. Now this completes our iteration. So the next iteration says that again we have to check bit pair. So bit pair says that it is 0 1, and 0 1 operation results in a is equals to a plus m. So a is equals to a plus m, which means that we are going to add the current value of a with m. So the current value of a is 1111, and the value of m is 0011. 1 plus 1 is 10. It means that the carry is been generated. So 1 plus 1 plus 1 is 1 1, carry is generated. 1 plus 1 is 0, carry is generated. 1 plus 1 is 0, carry is generated. Since the variable a is able to hold only 4 bits, it means that this carry which has been generated needs to be ignored. So the value becomes 0010. Here it remains same. Okay. Now in this equation, one operation is will remain, that is ASR and n minus 1. So it means that this will result in n to be 1, and we have to perform arithmetic shift right. So it means that this 0 is being shifted over here, and this operation needs to be done. So this becomes 0001, and this 0 comes over here, 0011, and this 0 comes over here. This will result in the value which is 0001 and 0011. Now this equation completes. So again we are going to check 1 0 because still n is not 0. So it means that we are going to check the bit pair 1 0. This tells us about the operation need to be performed is a is equals to a minus m. So current value of a is 0001, and the 2's complement equivalent of m is 1101, which we have already calculated earlier. So we are going to perform addition. 1 plus 1 is 0, 1 carry, 1 plus 0 is 0, 1, 1 and 1. So it means that the value of A is 1, 1, 1, 0 and 0, 0, 1, 1 as it is. And lastly, we are going to perform ASR to complete our expression. So it means that this values need to be shifted and decrementing n by 1, that is 0. So this results in 1, 1, 1, 1. This has been shifted over here. This 0 has been shifted over here. It will result in 0, 0, 0, 1, and this 1 is shifted over here. This will result 1. So finally, we have to focus upon these 8 bits. So this will be 1111, 0011. This is equivalent to what we have obtained by multiplication, decimal multiplication that we have done earlier.